Until the moment humans first realized that light wasn't just instantaneous, until the time they dared to question something so obvious, the universe seemed boundless, mysterious, and unmeasurable. Imagine living in a world where sunlight appears the instant you open your eyes, where fire illuminates the night as soon as it ignites, and yet, no one had any idea how fast that light actually traveled. For centuries, philosophers, astronomers, and thinkers assumed light must be infinite, traveling instantaneously from one place to another. Even brilliant minds like Aristotle and Ptolemy assumed that light traveled infinitely fast, because, in daily life, it seemed to appear the moment it was emitted. But the truth, as it turns out, was far stranger and far more measurable than anyone imagined. The story of measuring the speed of light begins in the year 1676 with a man named Ole Romer, and it forever changed how we understand the universe. Romer was a Danish astronomer working at the Royal Observatory in Paris. Night after night, he pointed his telescope at Jupiter, carefully tracking its moons, particularly Io, the innermost of the four largest. His job was simple in theory: predict the timing of Io's eclipses as it passed into Jupiter's shadow. But Romer noticed something puzzling. Sometimes, Io appeared to be late, arriving after the predicted time. Other times, it arrived early. Observers initially blamed the discrepancy on poor equipment, weather conditions, or human error, but Romer suspected something more profound. Could it be that the delay was not in Io, but in the light traveling from Jupiter to Earth? Could light take time to cross the vast distances of space? Romer began tracking Io's eclipses meticulously, recording each timing with extreme precision over months and years. He noticed a fascinating pattern. The discrepancy in Io's timing grew as Earth moved away from Jupiter in its orbit and shrank as Earth moved closer. From this, he made a revolutionary conclusion. Light has a finite speed. Using the known distance between Earth and Jupiter at different points in their orbits, Romer estimated that light would take about 22 minutes to cross the diameter of Earth's orbit. It wasn't exact by modern standards, but it was the first quantitative evidence that light travels at a measurable speed. For the first time, the notion of light as instantaneous was disproven. This was a radical idea. At the time, most scientists still assumed light traveled infinitely fast, and the concept of a measurable speed was hard to accept. Romer's calculations caused debate across Europe. Some astronomers argued that the variation in Io's eclipses could be due to unknown irregularities in its orbit rather than the speed of light. But Romer stood by his observations. His work laid the foundation for a new understanding. Light was a physical phenomenon that obeyed laws, just like motion, gravity, or planetary orbits. Even before Romer, Galileo Galilei had attempted to measure the speed of light. In the early 1600s, he and an assistant used lanterns on distant hills. They would uncover one lantern, and the other assistant would respond by uncovering another. Galileo hoped to detect a delay in the return of light, but the experiment failed. The distance was too short, and light is simply too fast for human perception over terrestrial scales. Still, Galileo's attempt was important. It marked the birth of experimental thinking about light. Measuring rather than assuming would become the hallmark of scientific progress. Nearly 170 years after Romer, a French physicist named Hippolyte Fizeau tackled the problem with a daring laboratory experiment. Instead of observing moons, he used a beam of light, a spinning toothed wheel, and a distant mirror. Here's how it worked. Light passed through a gap in the spinning wheel, traveled several kilometers to the mirror, and reflected back. If the wheel was spinning at the right speed, the returning light would be blocked by the next tooth. By knowing the exact distance to the mirror and the rotational speed of the wheel, Fizeau could calculate the speed of light. It was a mechanical solution to a cosmic question, turning the invisible into something measurable. Fizeau's measurements were astonishing. He calculated the speed of light as roughly 313,000 kilometers per second, remarkably close to the modern value. His experiment demonstrated for the first time that the speed of light could be measured on Earth. With precision and reproducibility, this was no longer a philosophical debate. Light now had a number, a concrete speed, and science could study it with confidence. But the quest for accuracy didn't stop there. About a decade later, Léon Foucault refined the measurement using a rotating mirror instead of a toothed wheel. In Foucault's setup, a beam of light bounced off a spinning mirror toward a stationary mirror several hundred meters away. The rotation caused a slight angular shift in the returning light. which could be measured with extreme precision. Using geometry and timing, Foucault calculated the speed of light as about 298,000 kilometers per second, astonishingly close to the modern accepted value of 299,792 kilometers per second. His work confirmed and improved upon both Romer and Fizeau, proving that the speed of light was a physical constant that could be measured repeatedly with ever greater precision. What makes these experiments so remarkable is not just the numbers, but the human ingenuity behind them. Romer deduced a finite speed from a moon's subtle delays millions of kilometers away. Fizeau transformed a spinning wheel into a cosmic stopwatch. Foucault devised a system so precise it could detect shifts smaller than the width of a human hair. Together, they transformed light from a philosophical abstraction into a measurable, physical reality. The story also highlights the drama of scientific discovery. Romer's findings were initially met with skepticism. Some astronomers dismissed his conclusions, arguing that moons couldn't reveal the secrets of light. Fizeau risked ridicule by claiming he could measure something invisible using a simple mechanical setup. Foucault worked in secrecy for months, perfecting the alignment of mirrors and rotations, knowing that any error could discredit the experiment. Romer, Fizeau, and Foucault didn't just measure light, they helped set the stage for the modern age of physics, including relativity and quantum theory. From Jupiter's moon to spinning wheels, rotating mirrors, and later lasers and atomic clocks, the journey to measure the speed of light is a story of curiosity triumphing over limits, of patience turning subtle observations into universal truths. It's a story of human imagination confronting one of nature's fastest mysteries and succeeding where philosophy alone could not. And when we reflect on this, it's clear that the discovery of light's speed is not just about a number. It's about the power of observation, creativity, and daring to question assumptions. It reminds us that the universe only reveals its secrets to those who notice the subtle, the delayed, the overlooked, and the seemingly impossible.